In this video, we're going to be taking a look at the HDF5 file format and some of its applications to financial data. I'm going to be comparing it to CSV and showing the pros and cons and why you might want to consider using HDF to store your financial data, whether that be trade data, open, high, low, close data, quote data, etc., etc. The HDF file format is maintained by the HDF group, and the HDF software itself is fully open source and free. It's become very, very popular within the scientific community because it's very, very easy to structure data and transfer it in a way that's very understandable when you receive it, for reasons that we'll see in a bit. And so I've got a notebook prepared here to run us through a few applications of how this might be useful for you. So the first one here is that we can have multiple symbols in one file without using a sim column and without having to load in all of the other data from the other symbols. So I'll show you what's going on here. So we're going to be using pandas throughout this tutorial to interact with HDF. Under the surface, pandas is using PyTables to create these HDF files, but pandas provides a nice interface, and so we might as well use that. So import pandas as usual. And I've got this file here on my computer called dailyuniverse.h5, and that contains daily data for all of the S&P 500 that I could scrape from Yahoo Finance. It's all contained within one simple file, so it's just here. It's this file here, 269 megabytes in size, which is reasonably large. And you can imagine if we had 10,000 different stocks in there, this might get into the 5 or so gigabyte range, which is already very difficult to fit into RAM. So what we can do here is I'll uncomment this line here. So with pdf.hdf_store, then the name as F. So this is using a context manager here to make sure the file is properly opened and closed. We'll see an example without a context manager later on, show you how that works. This HDF store here behaves very much like a dictionary. So if I print out a list of keys here, you'll be able to see all of the different elements here. So I've got the full S&P 500. And if I want to, I can print the data for a particular key. So you can see here, I'm asking for Apple. Again, very, very much like interacting with a dictionary. So I can pull all of the Apple data there. That was very, very quick, as I'm sure you noticed. If I wanted to get the Microsoft data, again, very, very fast. And so if you've got a large amount of data, let's say this was Minutely data, it's very, very convenient to have this located all within one file. And thanks to the magic of HDF, the more data you add in a file, the more different symbols we add here. You really don't get any massive amount of overhead like you would in a CSV. If this were a CSV file, we'd have to load in all the data for all the symbols and then filter it down to the one we want. With a HDF, it's a matter of just asking for the key that we want. You don't have to have a whole folder full of different CSVs. It's just one super simple file. So that's pretty cool. You can store lots of data for lots of different symbols all in one file. It can be gigabytes or even terabytes. It doesn't have to fit in your RAM at all. And we can request just the data we're after with minimal overhead. If you're interested in creating this file, this is how I did it. I just imported Y Finance here, and then for symbol in a big list of symbols, we get the data from Y Finance, and then we use this to_HDF function here, which is available on every pandas data frame. It's exactly like the to CSV, except obviously it's saving down to HDF. You save down to the file name that you'd like. You provide a key, which is how we access it here. So the key is obviously the symbol in our case. And then mode is going to be append. And that way we don't overwrite the data here. you can see there's a few different options here. So if you use write, the file would be deleted, and we don't want that. And R+ requires the file to exist. So I think A is the correct mode here. And so I'll run this here just for these few symbols, and you'll get to see how it works. Need to import Y-Finance first. There we go. Those are our 3 tickers here. If I look inside my folder, I've got a Daily Universe 2, 600 kilobytes in size, and I can come and load that up with my context manager here. So I think I had metadata in there. Yes, meta. So I'll load that. And there you go. So this is nice and all, but we've been dealing with very, very small files here relatively. And so I thought in the next example here, I'd show you how HDF can come to the rescue when dealing with extremely large files if you've got a lot of financial data. So I've got a big CSV here that I downloaded from Binance. It's 13 gigabytes and it's full of BTC USD trades for the month of September in 2022. So every BTC USD trade that happened during that month, as you can imagine, it's quite a few rows. I think I have it printed out up here. It's 175 million lines. It's an extremely large CSV. And I only have 16 gigabytes of memory. And so if I want to load this into Python, it's going to really, really struggle. And in fact, the last time I tried it, the kernel completely broke. So I can show you what happens here if I try and load it in. It's going to progressively take up more and more of my RAM until the kernel eventually breaks here. So there we go. You can see everything just broke there. It killed the kernel. It couldn't load in the data. That's what happens when we have these massive CSVs. Say you got this from some external source like I did, or you've been writing trade data down to a CSV during the day, and then you come to import it at the end of the day and you realize that you can't do that. This is obviously very bad for when we want to do some kind of analysis. So how does HDF save us here? Well, I've got this exact data here, so all 175 million lines, inside a HDF file. So on disk, if I show you here, the CSV is 13 gigabytes, as you can see down here. And the exact same data in a HDF file is only 7.5 gigabytes. I didn't do anything fancy, compression's turned off by default in pandas. And so that's already saving a good bit of space there, and might well be a good enough reason to use HDF as it is. But as I mentioned previously, HDF has this magical property that you can load the file here, but no data will be moved into memory until you actually request that data. And the beautiful thing that we can do is we can add some where clauses in here. So I'm going to load this HDF. I'm going to select the BTC USDT data. So that's going to be the key, like the one we saw earlier. And I'm going to request that for a particular time. So this is a 1 hour chunk of data out of the month. Let's see how quickly this runs here. So I'll make sure to import pandas here. Let's see how quickly this runs. So that was the whole thing there. That's going through that massive file and just finding the information that we want. You can imagine how horrendously difficult this would be to load in using a CSV. You could definitely get around it by using chunking or something similar, but HDF just makes it very, very simple and intuitive. So this timestamp here is for the 5th of September at midnight to the 5th of September at 1 a.m. Just to show you that I'm not doing any magic here, let's switch these epoch times around so I can show you that it still works just as well here. So I'll grab this one from over here. So this is the 10th of September at midnight. And then I'll also grab the epoch time for the 10th of September at 1 a.m. Again, run that very, very, very quick. going through this tremendously large file here. And there's no practical limit really. The file can be terabytes in size if need be, as long as your operating system can support that. And so we can see that as far as large files go here, HDF absolutely destroys CSVs, at least in terms of convenience and loading time. You can do the same sort of system with a CSV file or multiple CSV files, but it's a lot more overhead and work on your end. If you want to see how I created this HDF file here, I have a chunk of code down here. Basically, I just did the chunked approach, so I loaded this CSV file as an iterator, which you can do using pandas, and I used a chunk size of 10 million, so we get 10 million rows at a time. I created a new HDF store object here, so it's just called BTC USD trades.h5 with write mode enabled, so it just gets rid of anything that's already there. And then I iterated through each of these chunks, so each of the 10 million rows, and I appended that to this key. Pretty simple really, just a way of converting from a very large CSV to a HDF that's much more easily manageable for us. The details around what functions you can call on this HDF store you can find in the pandas documentation. So if you look for hdf.put, hdfstore.append, they're all in here for the most part. There's also a cookbook here. If you go look for the pandas cookbook, you'll be able to find some more information about HDF stores. And if you can't find it there, because this is rather a niche topic, you'll have to trawl through the code and actually find where HDF store is defined, which is on line 478 of this file here, at least at the time of this video. Just to show here that it's definitely the same file with the same amount of data, I can open it up and I can ask for some information about the table. So you can ask here for the amount of rows, and you'll see that is indeed 175 million rows. So we have all the same data, just a double check here. You can also add compression here when you're saving down. So I've got a comment here, but inside here, you can add something like comp level is equal to a number from, I think, 0 to 9, where 0 is compression off, 9 is maximum compression. There are also a few different compression algorithms to pick from if you particularly care about certain algorithms. But that again will reduce the footprint on disk here. So this is one that's been maximally compressed, and that's down to 3.4 gigabytes. So we had this 13 gigabyte CSV. Just putting it in a H5 format took us down to 7.5. And then compressing took us all the way down to 3.4. And I did a few tests and loaded some data from it, and there was very, very minimal overhead, which can make H5 files a really awesome way to archive data over the long term, because you can massively compress it, store it away, it's just a regular file sitting on your drive, and it'll be there anytime you need to access that data later on. So if we were to make some comparisons here between HDF and other methods of storing data versus the CSV, the pros are you don't have to fit the whole file in memory. Your file can be terabytes and terabytes long, and HDF doesn't care, it just gets the information that it needs. It's also a really nice way of combining multiple sets of data in a folder-like format into one file. So I just had the trades there, but I could have also kept data about the quotes or futures information in a subgroup of that group that we indexed into earlier. And that would have been a really nice way to organize the information. And of course, we have partial I/O, which means that if we're only after certain rows or certain columns of data, HDF can retrieve those for us very easily and quickly. The cons mainly being that it's not plain text the same way as a CSV is. So some of you might be slightly paranoid about losing data. I know I am often. CSV can be quite reassuring in that it's just straight up text and therefore very, very easy to read, portable, and that kind of thing. There's also a larger learning curve required when using HDF. It's not as simple as just slapping something down to a CSV, and you have to think a little bit more when you want to save down data. You'll want to think about the structure of the data, how you want to save it. And if you really want to optimize things to the max, you'll have to go and look in Pi tables and dig really deep into the technical details. I think to some extent, HDF files can compete with a traditional database or even a time series database like Timescale, especially for something like backtesting where the data's not being updated very often. It saves the hassle of having to manage a full-on database. You've just got this file on your system that you can shove on a hard drive, you can move anywhere, very, very portable, very easily. If you want to find out more information about HDF files and more of the theory of how they actually work, I'd recommend this excellent YouTube series by the HDF5 group here. There's a nice playlist of, I think, 11 different videos. I found it to be a really helpful introduction. And so that's it for this video. Let me know what you think about HDF files, whether you've used them before, and your experiences with them so far. And with that being said, I'll see you in the next video.